Alright, it's time to install or assemble the hot end. This is probably one of the trickiest pieces to get working, so there is a trick to it. Let me show it to you. The screws right here, I've went ahead and installed the lock nuts on them, and they're all a little bit loose as far as holding the hot end onto the metal bracket there. So what you do is you get a zip tie and put it on there. Get all the screws, relatively tight against it, and then tighten up the zip tie. That will keep all of the screws nice and tight up against the hot end there, and you'll be able to adjust the center of it to right in the center of the bracket. And then go ahead and tighten the screws. This will ensure that the hot end is securely tightened onto the bracket. You might need to loosen it and adjust it a little bit, but really that is a solid connection there, and there's no way that that's gonna move. Go ahead and keep the zip tie on there. It can't hurt anything. I went ahead and loaded the screws. These are some screws without threading right here. I've got a number 5 washer, the spring, and another washer on there. These go right into the small holes on the end of the bracket. Then another washer and a lock nut. Now go ahead and tighten up the lock nut almost to the end of the threads. And that's really where you want it to be. Do the same on the others. So the end effector plastic piece here has 3 holes, and they are purposely not threaded. The plastic will grip onto these screws, and if I thread it, then it won't grip quite as hard. So it is purposefully not threaded, and the intention is to screw these in so they're nice and tight. Make sure that they go in perpendicular to the plastic. This may take a little bit of practice, but really we want to screw these things in until the end of the screw is pretty much to the end of the plastic there. Do this for each of them, and then when you're done, you'll have a spring-loaded effector that can really be upgraded almost as easily as changing these 3 screws. There we go. You can adjust how perpendicular the hot end is to the bracket there just by adjusting these screws. And if you have a 3-headed design, you can adjust the height of the height of the nozzle above the build plate just by adjusting these 3 screws. When it comes time to install the magnets, these are the magnets that are really have a magnetic field that shoots out at about a 45-degree angle. They go in there with a number 4 lock nut there. I should mention that I like to use this little washer there. I'll go ahead and include it with the kit. that make sure that it stays nice and level on the top surface. When you assemble these magnets, make sure that these two, the magnetic field point out at the same angle. Same with those two and those two. And really, that's about it. Alright, it's time to assemble the slider. The magnets that go in here are the ones that with the magnetic field pointing straight out the top, and they go on with a simple nut on the back end. The nut will stick to the screw because of the magnetic field. Just tighten that up with a pair of pliers and do that for both of them. These bearings, I use 4 of them because it's the most secure. 2 of them utilize the offset hole there so that you can adjust them once they're on the maker slide. I put the offset nut in from the top. Now there's 2 different sizes of screws. The 18mm screws are used on just the metal, and the 20mm screws are used with the offset nut. So these go on with a number 5 washer, and they go on from the back with a lock nut. The same process is used with the 18mm with a number 5 washer on this side with a lock nut. Now the 2 screws that hold the belt are the M4 screws here. They go on with 2 nuts. And once you tighten that up with a pair of pliers, it will be pretty much done. As you can see, it's fairly easy to assemble these sliders. If you wanted to use just 3, you could utilize the center hole here, and that will give pretty much the same results, but I like to use 4 just for the added security of a nice, tight, and accurate print. Here's how I do the belts. These belts were ordered in a 10-meter length. I have cut them to 82 inches long, and when I fold them over, I want to make sure that I have enough, about 1.5 inches or more of overlap there, so that when I put the zip tie on, I can put more than 1 zip tie. Now when you make the loop, make it just the right size so that it fits over the head of the screw on the slider and pulls tight. Since you will want multiple zip ties on there, it's going to look like that once it's on the printer. And do this for both sides of the belt, and that's it. During the belt assembly video, I mentioned that 82 inches was the recommended length of the belt. Once I put the machine together, I noticed that about 80 inches was all that's necessary. So that allows just enough room down here at the bottom to adjust these with a screwdriver. If you do use the taller bed springs right here, you probably want to go with like about 76 to 78 inches on the belt. That will move this block up a little bit higher and allow you to access it with a screwdriver.
I wanted to mention that the zip ties here that hold the belt, you want to make sure that the head of the zip tie is on the outside, pointing in toward the printer, because as the slider goes up and touches the limit switch, you don't want the zip ties to make contact with the switch or the switch block.
Assembling the pulley block almost couldn't be easier. This is a pulley I purchased from inventables.com. It gets installed with a 20mm M5 screw with a little washer on there, and it gets threaded right onto the pulley block itself. When this is installed on the printer, it'll go on the bottom of the maker slide, and it will be installed with a 14mm M5 screw. The screw will go into one of the extra extrusion nuts that you put on the inside of the maker slide. It's time to install the motor bracket. You definitely want to install the bracket onto the plastic before you put the motor into the bracket. Now when I designed this, I made sure that the edge of the hole here lines up and is flush with the end of the bracket. So that's basically where you want it. You'll notice that the holes in the plastic are really kind of centered on the bracket itself. So install 14mm M4 screws into the holes. And use some M4 lock washers or lock nuts to tighten up the screws and make sure this doesn't go anywhere. Once again, make sure that this right here is flush. That should give you the most options for installing the motor. When you do put the motor on, you'll want to make sure that the belt goes into the center of the hole this way. Here is the contents of the limit switch kit. The first thing you want to do is put one of these nuts into the little slot right there. That will allow adjustment once it gets installed on the printer. The switches themselves get installed just like this with 2 screws. And you want the switch to be on the inside of the part. You may actually want to solder the wires onto the switches before you screw it on there. But really, once it gets in the printer, this screw will go down the top of the plastic piece, and it will screw in here and allow you to adjust this up and down ever so slightly. And you should have already put in one of these onto the maker slide on the inside channel of it. When it gets in the printer, you simply install a screw onto it. I did include a little hole right there for you to stick a paper clip or something in there, and that will hold this piece up to the right height if you've got it upright when you're trying to assemble it. So if you do need that hole, that's what it's there for. And then you can adjust it using a screwdriver from the top. Make sure you press down to make sure that the head of the screw makes contact with the top plastic piece. You could put a spring right here if you wanted to, but I really don't think it's that necessary as long as you press down with a screwdriver. That's it for the assembly of the limit switches. Okay, there's nothing fancy about the assembly of the plate holder for the hotbed. When you do assemble this, make sure that the outside of the metal here is the thin edge. That way you can use some clamps to keep your hotbed on. If you do it this way, there's really nothing to clamp to, so you know, just make sure you have that outside edge. I went ahead and pre-installed these screws. They take they're 14mm screws, and they're going to take a M5 nut with a one of those star washers on there. Tighten those up and do it for each of the corners, and that's really all there is to it. For this particular build, I use just a standard aluminum plate as the bed. Later on in the future, I can upgrade to a glass surface with a heater underneath, but for right now this is what I had, and it actually works quite well. During the assembly, I noticed I did have to drill out the hole in the plastic a little bit, just so that it slides really nice on the bolt without moving too much in XY direction. Everything else, the holes were just about right. The mounting of the electronics is always a big question for any build. On this particular one, I decided to mount the Teague board right on top of the hole. This allows me access underneath if I need it to. Also, this allows me to adjust the wiring needed for the display, and you know, all the wires going to the hot end go straight down here, so it makes it fairly clean. I like the fact that the power supply is up here. I used the short bed springs and made sure that the bed is really close to the bottom of the frame there, which means I did not use the power supply underneath the bed like I did on my first one. So with the power supply up here, there's just a short power wire to the electronic board. It's much simpler. In fact, in this one, I went straight from the power supply to an on-off switch and then to the board. So it didn't require very much wire at all. If I need to adjust anything, it's all right here on top, easy to get to. I still mounted my display on the top. This allows me to use it without the kids changing settings during a print. So I think this build really worked out quite well as far as the organization of the electronics and overall you know, ease of use of and maintaining it. Here is the filament holder that I ended up using on this machine. It's just a T fitting on a PVC pipe. I cut the fitting, drilled some holes, and that's all there is to it. Nothing complicated about it. It's a nice solid method for keeping the spool, and I use these little clamp things to keep the spool from walking off during a print. I've been using this method on the other machine for quite a few months now. I really like it. Nice and simple. Don't know how well it's gonna show up on the video, but there is a lot of grease right here on the balls. One of the most important things to do when assembling this machine is to put some grease inside the screw cap there, and keep that nice and lubricated. If those are not lubricated, they will scratch the surface of the magnetic of the magnet, and it will chip off the chrome plating, and you will have problems. Prints will fail because if that plating gets damaged, then the movement gets hung up on the damaged part, and then
your head will not move like it should, and it will make contact with the print and basically pull away from the rest of the magnets, and it's not pretty. So I do recommend lubricating each of the balls, even up on the sliders as well. Those need to be thoroughly lubricated, and I change the lubrication about once a month. Whenever it starts getting a little bit black, it's time to put some more in there. I use standard automotive grease, nothing special about it, just as long as there's plenty of grease there, it should work just fine. Here is a completed TRESTLE 3D printer. Right now it's printing at over 80 millimeters a second. It's got an E3D Volcano hot end on it. I really like that hot end. It's working very well. This more or less represents a stock or recommended build. I did use Azteeg electronic board up there that runs the Smoothie firmware. I got a Vicky 2 display panel. Here is a geared extruder that I'm using. I downloaded all these files off Thingiverse. I really like that extruder. It does a fine job of making sure that the filament goes in nice and smooth, and I don't have any problems with it stalling the stepper motor either. I am using an aluminum plate as the hotbed. I just had the plate. I don't have a glass plate to put on there at the moment, so this seems to work just fine. I didn't put anything on the painter's tape to get it to stick. I'm printing PLA at 210 degrees centigrade and just over 80 millimeters per second.